Okay, so we are going to jump back to the homework problem that Mr. Murphy assigned you last class period. And this is a wonderful lead-in into what we're going to talk about today, which is confidence intervals for proportions. So let's go ahead and jump right in here. It says, a researcher has conducted a survey using a simple random sample of 50 registered voters to create a confidence interval to estimate the proportion of registered voters favoring the election of a certain candidate for mayor. Assume that the sample proportion does not change. Which of the following best describes the anticipated effect on the width of the confidence interval if the researchers were to survey a random sample of 200 rather than 50 registered voters? Okay, so here's the first thing to recognize. We started out with 50 as a sample size, and we are moving to 200. So very clearly, the sample size is increasing. And more specifically, I can see that the sample size is being multiplied by 4. So the question is, how is that going to affect the width of the confidence interval? Now, in order to answer that, we have to know something about confidence intervals. So I'm going to start with what I call the general formula for any confidence interval, which is the point estimate plus or minus the margin of error. Now that's the general formula. The specific formula, if you're trying to estimate a proportion, looks like this. P hat is your point estimate. Your margin of error has two parts, the critical value, Z star, and then the standard error of the statistic, which in this case is P hat 1 minus P hat all over N. And so let's think about what happens as this sample size increases, right? So if we have N increasing, right? N is going up. Well, you'll notice that N is in the denominator of that formula. And if the denominator is getting bigger, that means that the whole thing is going to be getting smaller. So that means that the margin of error is going to get smaller. And if the margin of error gets smaller, you're going to have a narrower confidence interval. So we know right away that this confidence interval is going to be narrower rather than wider. And so I think I can get rid of answer choice C says the same width, answer choice D says twice the width, and answer choice E says 4 times the width. So I can immediately eliminate those 3 answer choices. And we're left with only 2 possible choices now. A, which says that your interval is going to be 1/4 of what it started out as, and B, which says that it's going to be 1/2. Now, by instinct, you might say, well, look, we're multiplying by 4 and it's in the denominator, then the width of the interval should be 1/4. And you might think that answer choice A looks kind of appealing. But here's the thing. Look at the equation. If I take N and I multiply it by 4, right? So I'm having a 4 now in the denominator. The other way that I could write this, instead of putting a 4 in the denominator, I could put a 1/4 out in front. And you will notice that this is underneath the square root. So when you take the square root of 1/4, you are going to get 1/2. And you will now have 1/2 times the old standard error, right? This is exactly what it was before. Everything else remains the same. And so what this is telling you is that your margin of error is going to be 1/2 of what it started out as, which means that it's going to be narrower by a factor of 1/2. And so sure enough, answer choice B is the correct answer on this one. So hopefully you did okay on that. I think we are now ready to jump into the new lesson for today. So the way that I typically go about this is I like to give you an overview just so that you know where we're headed in this particular lesson. And we've got 2 learning targets for today, both of which are about confidence intervals. So the first one says, construct and interpret a confidence interval for a population proportion. Okay, that's one proportion. Whereas learning target number 2 says construct and interpret a confidence interval for a difference of 2 population proportions. Okay, so the first learning target is going to be 1 sample inference. The second learning target is going to be 2 sample inference, where we're looking for the difference in the population proportions. And you'll notice that for each one of these, we're going to use the familiar 4-step process in order to write up our solution. And I will do my best to try and point out some very key AP exam tips that I've learned over the years of grading AP exams. All right, so let's jump right into the activity for today. And here's the ultimate question that we're trying to answer in today's activity. Do you want to take the AP exam? And we are going to make a little bit of comparison between AP statistics students and AP calculus students here. So here's what it says. I'm just starting out right at the top here. A random sample of 300 AP statistics students revealed that 92% of them wanted to take the AP exam. All right, let me pause right there. That 92% comes from my sample, and it is a proportion. So I'm going to use the correct notation here, and I'm going to call that p hat for sample proportion, and I'm going to write it as a proportion rather than as a percent. So we do have a sample proportion right now. Construct and interpret a 95% confidence interval for the true proportion of all AP statistics students who want to take the AP exam. All right, so you'll see our state plan do conclude, and I've given us some hints about what needs to be included in each step. So let's start with the state here. And we need to first identify what is the parameter for the population that we're trying to estimate here with our confidence interval. Well, we know our statistic is p hat. The parameter that we're trying to estimate, is just p, no hat on this one, just p, which is going to represent the true proportion of all AP Stats students who want to take the AP exam. Now, very important here, there's a couple of words that I've used here to make it very clear that the parameter is referring to the population of all AP Stats students and not this sample of 300. And the words I'm referring to are true and all, just to make that crystal clear that we're referring to the population. We're trying to make inference about the population here. All right, now our confidence level here is given to us in the problem, and probably the most common confidence level that we're going to see is a 95% confidence interval. All right, we can move to our plan now. First, to identify the name of the procedure. So first thing I want to reference is the fact that we only have one proportion here because this is based on one sample. Because we are estimating proportions, we are going to be using normal distributions, which means this will be a z interval. And then I'd like to make it very clear what it is that I'm trying to estimate here, which is a single proportion p. So we are now ready to check our conditions, and there are 3 of them that we would like to check here, starting with the random condition here. And we want to check that we have, in fact, a random sample. And this is where I like to actually just steal the words right from the question here. And the question says that we have a random sample of 300 AP Stats students. So you'll notice I'm putting these in quotes just to make it very clear that I have just stolen those words right from the stem of the question. Now, we should check in on why we are checking these conditions here. The random condition says that we have a random sample. And the reason why that's important is because if it is in fact a random sample, it should be representative of the population, and therefore we can generalize our results to the whole population, right? So let's say that that condition there is satisfied. Now the next condition, the 10% condition, is one that we have to check only when we are sampling without replacement. Well, it's most likely that this sample was a sample without replacement. They probably didn't take one student out, sample them, and then put them back in the pool so that they could get selected again. So I do think that we need to check the 10% condition here, which is to say that the sample size, 300, is less than or equal to 10% of the whole population. And the whole population here is all AP Stats students. And we know that there are over 200,000 students that take the AP Stats exam every year. So definitely we are safe with the 10% condition here. And the reason why that's important is that's telling us that sampling without replacement is okay here. And we don't have to worry about the independence condition not being satisfied because we're sampling too much of the population. All right, we are ready for our third condition, which I call the large counts condition. You may see it as the normal condition depending on your textbook. And this is the one that says that n times p and n times 1 minus p are both greater than or equal to 10. Except one small thing that we need to make sure of here. N times p, well, p is the true proportion of all AP Stat students who want to take the exam. We don't know the true proportion. In fact, that's the whole reason we're doing a confidence interval, is to try to estimate that. So very important here, this should be a p hat because we're going to use our sample proportion because we don't know what the population proportion is. So let me plug in some values. 300 is our sample size. The sample proportion is 92%, 0.92. That's going to give me 276. And then 300 times 1 minus p is 0.08. That's going to be 24. Now, what we're really getting there is the number of successes, 276 students who want to take the exam, and the number of failures, 24 that do not. And we need to check that both of them are greater than or equal to 10. And sure enough, they are. Now, let's check in with why we need to check the large counts condition. And the reason is because we want to be able to say that the sampling distribution of p hat is approximately normal, so that we can use a z star critical value when we get to the calculation. So with our three conditions satisfied, we are ready to move on to the actual work of calculating the confidence interval here. So we're going to start with a general formula, which I actually showed you on the homework from the previous day. Point estimate plus or minus margin of error. Now, there is another general formula that's given to you on the formula sheet for the AP exam, and it looks like this. Statistic plus or minus. Now, they're going to break the margin of error down into its two components, which is the critical value multiplied by the standard error of the statistic. Now, we would like to be able to make this a specific formula for when you are trying to estimate a single proportion. All right, so let's be careful of our notation here. The statistic is the proportion based on the sample, which is our p hat, plus or minus our critical value. We know is going to be a z star critical value, which comes from a normal distribution. And then the formula for the standard error of the statistic here is the square root of p hat 1 minus p hat all divided by n. And we are finally ready to plug in some numbers for this thing here. We know our sample proportion p hat was 0.92. Now, we need a z star value, the critical value, which tells you how many standard deviations or how many standard errors away from the mean we need to go in order to get that 95% confidence. And for this, we are going to need either table A or table B, which is given to you on your formula sheet. I'm going to sort of shortcut a little bit here and use table B, which is for t distributions. But if you scroll all the way down to the bottom, where you have degrees of freedom infinity here, that is actually a normal distribution because a t distribution approaches a normal distribution. And what we have down there in that last row is the z star critical values. And sure enough, 95%. I'm actually really hoping that you already know this one because you've seen it so much, is 1.960. So I'm just going to go ahead and put that in for my z star value. And then my standard error is the square root of 0.92 times 0.08, all divided by the sample size of 300. And I've already done a little bit of the calculator work here. So it's 0.92 plus or minus, and we end up with, for our margin of error, 0.031, which will allow us to write our final confidence interval. I'm going to put this in parentheses here as 0.889 up to 0.951. And we are ready to make a conclusion to interpret this confidence interval. And there's a pretty standard interpretation that we're going to use anytime we're interpreting or making a conclusion for a confidence interval. And here's how it's going to start. We are 95% confident that the interval from, and then we need to give our interval here, 0.889 to 0.951, captures the true, and now here's the thing, we need to write out what our parameter is here. And I've already identified it up here. So essentially, I'm just taking that word for word, which, by the way, just came from the stem of the question. So a little AP exam tip here is if you just use the words from the question, you're not likely to make a mistake with that. So let's just finish this one off with the true proportion of all AP Stat students who want to take the exam. Now, a couple of things I want to highlight here in the conclusion. One is to make sure that we are using the word confident here. You're not saying 95% chance. You're not saying 95% probability. And then the other thing is to make clear that we're trying to estimate something about the population. So once again, we've used in true and all, and we've made it very clear that the thing that we're trying to estimate is a proportion. And then you'll notice at the very end of this, there is some context there. So we're putting the context of the question. Okay, so last thing I want to mention here before we move on, I looked back through a couple of rubrics from the past couple of years, and I want to let you know specifically what needs to be included on this. Okay, first thing is to identify the correct procedure. And there are two ways that you can do this, identifying the correct procedure. The easiest way is to just identify the procedure. One sample is the interval for P. But you can also get credit down here where you've written the formula for that. That also gives you credit for identifying the correct procedure. Don't have to have both, have to have one out of the two. Okay, the next thing that you're going to want to make sure you do is to check conditions. If you look at rubrics from years past, you're probably going to see this one, the random condition, and this one, the large counts condition, but you might not see the 10% condition until last year. 2019 was the first time that we saw the 10% condition. I think in line with the new College Board CED, this is something you can expect to see on the rubric. So if you are sampling without replacement, make sure you're checking that 10% condition. And then the next thing is that you have the correct interval. And honestly, this right here is really the thing that the graders will be looking for, is that you have the correct interval. All of this other work here, I'm going to say is not required, but I really like to see it because a lot of times students can catch their mistakes if they're writing out all of their work. But according to the rubric, the interval is the thing that they're going to be looking for. And then of course, they're going to look at your conclusion and make sure you have a good conclusion there, which includes the word confident, includes inference about the population, is very clear that you're trying to estimate a proportion, and then somehow includes context. Now, I do want to check to make sure that you can do this on the calculator. I love using the calculator as a way to check my final answer here. So let's go ahead and get out your calculators if you have one, or you can just follow along with what I'm going to show you here. No need to have a calculator in front of you. Fairly straightforward in terms of using the calculator for this. So you go to Stat and you go over to Tests. And you start scrolling down, and we definitely want an interval here. And we want an interval with one proportion in it. So there it is. Choice A, the one proportion Z interval. So I'm going to hit enter on that. Now, what the calculator wants here is the number of successes and the number of trials. And we had, remember, 276 successes out of 300. And that number of successes always has to be an integer, right? You can't have a decimal here. So 276 out of 300, confidence level is already set at 95% for me. So I can go ahead and hit calculate. And sure enough, the interval that the calculator is giving us here is exactly the one that we got by doing it by hand within a rounding there. So we had 0.889 to 0.951. So that's a great way to check your work there. Now, that takes care of the one sample confidence intervals for a proportion. The next thing that we need to take a look at is a two sample where we're trying to find the difference between two proportions. So let's jump back into the activity here. And I'm going to add one more layer to the context that we've already started with here. So here's what it says. A random sample of 300 AP Stat students revealed that 92% of them wanted to take the AP exam. Okay, this is not anything new. This was on the previous page. Once again, I have a p-hat of 0.92 for my AP Statistics students. But let's continue on. A separate random sample of 200 AP Calculus students revealed that 89% of them wanted to take the AP exam. Well, now we've got another sample here and another proportion. So another p-hat value, which is 0.89. Now, to distinguish those two proportions, I'm going to call this first one P1 and the second one P2. And the question says, construct and interpret a 90% confidence interval for the true difference of proportions of all AP Stats students and all AP Calc students who want to take the AP exam. So what we're actually interested in here is the difference between the two proportions. So if we look at our sample proportions, 92% for AP Stats, 89% for AP Calc, we have a difference of proportions of 0.03 based on these two samples. Now, the parameter for the population that we're trying to estimate here now is the true difference in proportions. So this is going to be P1 minus P2, which I'm going to define as the true difference of proportions of all AP Stats and AP Calc students who want to take the AP exam. Now, I want to make it very clear right here the order with which I'm subtracting these two, because you could do statistics minus calculus or the other way around. And the way that we're setting this up is we are taking the AP Stats proportion and we are subtracting the AP Calc proportion. I'm just going to make that very clear here in my parameter. Now, the confidence level is given to you in the problem at 90%. All right, we are ready to name the procedure, which will sound almost like the one that we just did, except that now we have two samples rather than one. Now, because we are estimating proportions, it is still a Z interval because we'll be using a normal distribution. And the parameter that we're trying to estimate this time is the true difference in proportions, P1 minus P2. Now, you're going to notice here that the conditions are going to look strikingly similar to the confidence interval that we just did. Random, 10%, and large counts. The difference here is that now we're going to have twice as much work to do because we now have two samples and two populations rather than one. So the random condition, we need random samples of each one of the populations. And also very important here, those two random samples must be independent of each other. And I'll explain why when we get down to the formula for standard error. But we need independent random samples of, and we had 300 AP Stat students and 200 AP Calc students. So we do have two random samples. They are independent. We can say that that condition is satisfied, which means we can now generalize to both populations. Now, 10% condition, the sample size is less than 10% of the population for the AP Stat students, which we've already checked this. Certainly that's true. But we also want to check that the sample of AP Calc students is less than 10% of the population of all AP Calc students. And certainly both of those are going to be true, which means that sampling without replacement is going to be okay here. Large counts condition, well, we already did the large counts for the AP Stat students. Remember, we got our counts as 276 successes and 24 failures. But now we need to check this also for the AP Calculus students. So N times P hat here, 0.89, 178 successes for calculus, and number of failures is going to be 22. And all of those counts are greater than or equal to 10, which means that our large counts condition is satisfied. And remember, that means that the sampling distribution is going to be approximately normal here. And we can use a Z star for a critical value. Okay, let's move ahead to the general formula, which is going to look exactly the same as it did on the last interval, point estimate, plus or minus margin of error. But then we have the other version of that general formula, which is the one that we get from the AP exam. which says the statistic plus or minus the critical value multiplied by the standard error of the statistic. Now, a little bit more to the formula this time because we now have the difference between two proportions. So the statistic this time is the difference between the two sample proportions, P1 hat minus P2 hat. The critical value still have a normal distribution, which is Z star. Now, the standard error of the statistic is this big long formula. It is available on your formula sheet here, which says P1 hat 1 minus P1 hat all over N1 plus P2 hat 1 minus P2 hat all over N2. And what we're really doing here is we're adding the two variances together and then square rooting to turn it back into the standard deviation, which we are allowed to do because we have independent random samples. So let's plug some numbers in here. P1 hat 0.92, P2 hat 0.89, plus or minus. Now I need a Z star value for a 90% confidence interval rather than a 95%. So let me see here, 90% is my 1.645. So 1.645 is my Z star. Now I got to plug in some numbers here, 0.92 times 0.08 all over 300 plus 0.89 times 0.11 all divided by 200. So a little bit of calculator work here. I've got our answers. 0.03 was the difference in sample proportions, and the margin of error is 0.045. And so that is going to give us a final answer over here of negative 0.015 up to 0.075 as our final answer for the confidence interval. And we are ready to make a conclusion. So we know the general format of this. It's going to say, we are 90% confident that the interval from, and then here's our interval, negative 0.015 to 0.075, captures the, now the thing that we want to capture, remember, is the parameter, which really just comes from the stem of the problem, word for word. I'm going to copy that down here. The true difference of proportions of all AP Stats and AP Calc students who want to take the AP exam. And just to highlight a couple of things to make sure that you have them, we're definitely using the word confident there. We are referring to the population by using true and all. We are making it clear that we are trying to estimate a difference of proportions. And we are also including context of the problem there. Now, before we move on here, I just want to make a quick point. A question has come up about what happens if you switch the order of your subtraction. And so maybe instead of doing AP Stats minus AP Calc, you did AP Calc minus AP Stats. This is certainly okay, but it is going to change a couple of things here. When you look down at the work, this part right here is going to be switched around because you're switching the order, which means that this 0.03 is actually going to be a negative 0.03. And what you're going to end up with for your interval here is negative 0.075 up to positive 0.015, which is really telling you exactly the same thing as the interval above it. So either one of those is correct, as long as up here, you make sure you identify the order with which you are subtracting. All right, final question here. Based on the confidence interval, do we have convincing evidence that there is a difference in proportion of all AP Stats students and all AP Calc students who want to take the AP exam? Well, if we look at this interval, which goes from negative values up to positive values, those are all of our plausible values for the difference of proportions, some negative, some positive, which means that 0 is one of the plausible values. So the answer here is no. because 0 is contained in the 90% confidence interval, it's plausible that there's no difference, right? It is plausible there is no difference in those proportions. So to wrap this up, we do not have convincing evidence of a difference of proportions who want to take the AP exam. Okay, and I would like to show you this one on the calculator as well, just so that you can see how you can check your work. So if you grab your calculator, or if you just follow along with what I have here, I want to show you a 2 proportion Z interval. So you're going to have to go back to stat, go over to tests, scroll down. There's our 1 prop Z int, but we want the 2 prop Z int. So let's go ahead and hit enter there. And once again, we need the number of successes and the number of trials. So we know for AP Stats, it was 276 out of 300. And for AP Calc, it was 178 out of 200. And we are going to have to change our confidence level to 0.90 this time. We want a 90% confidence interval. And we hit calculate. And sure enough, with our rounding, we got by hand negative 0.015 and 0.075, which matches exactly with what we see on the calculator here. So now that you have seen both types of confidence intervals for 1 sample and 2 sample, I'd like to try and just go back to those 2 learning targets from the beginning of the lesson and make sure that we have everything that we need from this lesson to wrap up. So we're going to do that on the last page here, where it shows the important ideas. So I'm going to do this just by learning target, and there were 2. The first learning target, LT number 1, was for the 1 sample Z interval for a single proportion P. And I'm just going to like split this right in half here. And learning target number 2 was for the 2 sample Z interval for the difference of proportions P1 minus P2. And I'd just like to remind you of a couple of the important differences between these 2 confidence intervals. So let's start with the parameter, the thing that we're trying to estimate from the whole population. Well, for a 1 sample Z interval, it is a single proportion that we're trying to estimate. So we would say the true proportion of, and then we'd have to put some sort of context into the problem, but it is just 1 proportion, a single proportion. Whereas for the 2 sample Z interval, we're trying to estimate the difference between population proportions, which would I would identify as the true difference of proportions, and then some sort of context of the problem, right? Okay, next, let's make a quick list here of the conditions that must be checked for each one of these intervals. For a 1 sample, there are up to 3 conditions that would need to be checked. The random condition, the 10% condition if we're sampling without replacement, and the large counts condition. Now, when we move over to the 2 sample stuff, you're going to have the same 3 conditions here, but we need to be a little bit careful about this here. Okay, first of all, you have to realize that you're going to have to check all 3 of those conditions for now 2 samples from 2 populations. So I'm going to just put a little note here that we really have twice the amount of work to do, right? And the other thing I want to mention here is that for the random condition, if you have random samples, you do want to make sure that you say that there are independent random samples. And the other possibility here too is that you could have an experiment that utilizes random assignment, which would satisfy that same condition, the random condition. Okay, the last thing I want to make sure that we capture here is this, what I call the specific formula, because they are a little bit different from the one interval to the next interval. So for a one sample, we have our sample proportion, that's our point estimate, plus or minus the margin of error, which is the Z star critical value, times the standard error, which is p hat 1 minus p hat all over n. Now for the two sample stuff, you're going to have the difference of sample proportions as your point estimate, plus or minus the Z star critical value. And then this formula for standard error is a little bit bigger here, p1 hat 1 minus p1 hat all over n1 plus p2 hat 1 minus p2 hat all over n2. So there is a check your understanding problem. This will be your homework problem, one homework problem that you'll have to have done before Mr. Murphy starts class tomorrow at 2 o'clock. I'm super grateful that you all have checked in with me today. I hope that you're